Welcome. Today we're going to take a look at the ArrayList class. We'll break it down, look at the methods that it has, and we'll look at how you could go through and process items in the ArrayList using loops. It's going to be a lot of fun, so hang on. Way better than arrays, so you're going to really enjoy this. Okay, let's take a look at an ArrayList, and we'll break down what it is and a bunch of the methods that you can use with the ArrayList. So let's get going. So an ArrayList, basically, it's a class that stores an array. It's resizable. You can add items, remove items. So it basically gives you the ability to work with a dynamic array. So when you add items, the size increases. When you remove items, the size decreases. And so we'll look at all of these options as we go through. So creating an array list. Whenever you want to use an array list, the first thing that you have to do is you have to create a reference. In this case, I've created a reference to an array list called A+. Currently, it's pointing at nothing. Currently, it's null. In this example, I instantiate a new array list. Currently don't have anything pointing at it. Its size would be 0 at this point. Now I've connected my reference to my new array list. And so A+ is pointing at a new array list that currently has the size 0 because no items have been added to that array list yet. So here we've got 3 examples of creating an array list. We've got a reference called words, one called desnums, and one called nums. Words is pointing at an array list of strings. Decnums is pointing at an array list of doubles, and nums is pointing at an array list of integers. So here are the methods that we're going to be working on, or we're going to be using as we're working through labs and working through examples. You've got 2 forms of add. You've got a set method, a get method, a size, and a remove. So the add method, you have 2 versions of add. You have an add that takes just the value, and you have an add that takes a location and a value. When you're using just the add that just takes in the value, it adds the items at the end of the array list. So whenever we went through and created this array list and we added A+, and then we added rocks, and you were to print it at that point, it'd print out A+ rocks. And then when you come along and add 0 comp, it would put comp at the beginning and shift A+ and rocks towards the end one time. And then when you added in psi, it would put psi in between comp and A+, and you would end up with comp psi A+ rocks. So this is using both versions of the add method. This example is doing the same thing, except rather than working with strings, it's working with integers. Both versions of the add method are being used. We've got one where it's adding at the end, and then we have the other one where it's inserting values into particular positions and shifting the remaining values to the right. Here's the size method. The size method basically lets you know how many times you've added something to the array list. And in this example, I've added 5 values to the array list. I print out nums.size, and it gives me a value of 5. The get method. Once I've added items to the array list and I want to get an item at a particular location, I can use get. This is the same thing like working with an array when you put the brackets and you put a number inside the brackets. So here I have array.get0. That would be the same thing as if I had an array and I said array bracket 0 bracket. That would be equivalent of doing the array.get. So I added 23, then I added 11, then I added 12, then I added 65. So 0 is 23, 1 is 11, and 2 is 12, because I'm using the default add method that adds everything at the end. And here's the get method example again. This time I'm attempting to get an item beyond the end of the array list, right? So I have values at spots 0, 1, 2, and 3. I do not have a value at spot or position 4. So when I attempt to access that spot, that position, I get a runtime exception. Not what you're looking for. It's occasionally going to happen though. Here's the set method. This one's a little weird, right? For some reason, people think that add and set do the same thing. Well, if they did the same thing, they'd have the same name, essentially, if it was an overloading situation. But the set method goes to a particular location, a particular spot, and changes whatever was there before to a new value. So here I had 23 and 11, and I say set 1, 5. So it's going to go to position 1, which was 11, and change the 11 to a 5. And then I added 4 at the end. I told spot 0 to become 7, which means the 11 became 7. And then I added 53 at the end. Okay, so if I print it all out now, I get 7, 5, 4, and 53. So remember, the set method goes to a location and changes whatever was at that location, whatever value was there before. And it's kind of the same thing we were just doing a second ago. I'm just expanding that example. And now I do a print line. And I say print line ray.set1, 93. So when I say ray.set1, 93, it goes to position 1, changes the value that was there, which was a 5, to 93, and then it returns back the value that it changed, which is very handy. I mean, there's a lot of different situations where you could use this as you go through and work through different programs. And here with the set method, I'm attempting to set beyond the size of the array, the size of the array list. I'm going outside of where I have values, and it's going to explode, just like it would if you tried to access a value or change a value in an array beyond the length. Remove. Remove is a cool method. It's a little more dynamic than the ones that we're just looking at. The cool thing about remove is remove gets rid of a value at a position, and it changes the size of the array list. So with the add method, it added to the size. Every time you did an add, the size of the array list got bigger. When you do a remove, the size of the array list is decreased. So here I've added A and B, and I did a remove 0, which got rid of the A. Then I added C and D, and then I did another remove, which then got rid of the remaining B and left behind the C and the D. So notice that each time you do remove, the items are shifted towards 0. So everything shifts to the left as you remove the items. And here, same thing. I'm just going through, and this time I'm printing out the remove so that you can see what's going on, and I'm doing the same manipulations that I was doing in the prior example. All right, let's go take a look at some of these examples in action. Okay, enough looking at examples and talking about ArrayLists. Let's get in here and try out some code and make sure we understand how all this works. So in this example, I have nums. Nums is pointing at a new ArrayList. I add 34, then I add 11 at the end after the 34. I print out my ArrayList, and bam, what do I get? 34, 11. So pretty much what you'd expect. So now let's go in here. I'm going to add a new item at the end. I'm going to add in 18. I'm going to run it again. Now I'm going to get 34, 11, and 18. So it added 34. After the 34, it added 11. And then after the 11, it added 18. So I'm now going to use the other version of add, because we have two forms. We have one that just adds at the end, and then we have one that adds at a particular location and shifts everything else to the right. So now I'm going to add 34, 11, and let's say 0, 18. It's going to put 18 at spot 0 and shift the 34 and the 11 to the right. So let's make sure we got that. Boom. So now we have 18, 34, and 11, which is pretty much what you would expect based on the examples that we just looked at. So now let's use set. The set method goes in and changes what's at a particular location to something else. Let's fix that. So now I'm going to say 0, and I want to change 0 to 99. Okay, so now let's run this again. And what do you know? Now I get 99, 34, and 11. So the set method is the same as this code. Say nums was an array. So nums 0 equals 99. Okay, except with 1 equals not 2. We're not doing any evaluation. So nums.set 0, 99 would be the same thing as saying nums bracket 0 bracket equals 99 if this was an array. So all it's doing is going to an existing position and changing that value at that existing position. Okay, now we have two other methods to look at. We got to look at get, and then we have to look at remove. So now I said get 0. Get will go to a particular location, a particular spot, and get me the value that's there. So we currently have 99 sitting at position 0 at spot 0. So we run it, we get 99. Let's go in here and change this to 2. Run it again, and now we get 11. So this code right here is essentially the same as nums bracket to bracket, right? That bracket. There we go. So pretty much the same thing. So when I say nums.get to, I'm basically doing the same thing I would with an array if I just said array name bracket and location. So let's get rid of all this. Let's put this back to what it was. And now let's take a look at remove. So with the remove method, remove goes to a particular location and gets rid of that value. So if I say remove 0, it's going to go to 0 and take that value and remove it and shift all the items to the left. So we currently have 99 sitting at position 0. So let's run this again. Notice the 99 is gone. All I'm left with is 34 and 11. So now we're going to take these two statements and we're going to plug them in at the end. We're going to shift this down just a little bit so you can see it. So now we're going to remove what's at 0 twice. So we remove the 99, print it again, we get 34 and 11. We remove 0 again, we get rid of the 34, we print it out, we get 11. So notice each time we remove, the size goes down by 1, and all the items are shifted to the left until we run out of items. So two forms of add, one that adds at the end, one that adds a value at a specified location. The set method goes to an existing value and changes it, and remove removes whatever location we specify. So you don't have to say remove 0. You could come in here and say, just to make sure you got this, remove 1. And if we do remove 1, then it gets rid of the 11 instead of getting rid of the 34. So whatever number you put in the remove, it gets rid of the value at that spot, at that location. So we looked at all of the methods that exist with an array list, how to create an array list. So now let's put it all together with some loops so we can actually get some stuff, to get it to do some stuff. Because so far we haven't really written any code that's meaningful. Now when we start looping through and traversing the list with the loops, we can actually make it start to do things. And this is a big deal when writing any kind of program. The ability to go through multiple things and examine those things is an important component of writing pretty much any program. So here we have the standard traditional for loop. We have it going up to the size of the array list, and each time through we use get to print out a value at each of the specified positions or spots or locations, however you want to look at that. Same thing here. I've added in a couple values. I loop through the array list, print out each one using get. My loop is controlled by the size method from the array list. Pretty standard stuff. Here I have the for each loop. Hopefully everybody's comfortable with this. If you went through the video over arrays, spent a ton of time talking about the for each loop, definitely something that you need to be familiar with. My array list name in this example is a bunch of nums. Each time through the loop, the for each loop goes to a bunch of nums, gets the next value, puts it in items so that we can print it out inside of the for each loop. Same thing here. The only difference with this one is I'm using the integer class as my reference type for num. Doesn't matter with the boxing and auto boxing stuff that's going on behind the scenes. The difference between this example with int item and this one with integer num, pretty much the same thing. We'll break this down more as we go along. Just understand you can do it either way and it works fine. The specifics we'll get into later on. So here I have an array list called array. I've added a bunch of stuff. I used the for each loop to go through and print out each of the items that I've added to the array list. Same thing here. Only difference here is I'm using capital I integer instead of int. Really no difference at this point. So now let's take all this looping stuff with the methods that we have available to us, and let's actually get some work done. So what I want to do is I want to go through an array list and count how many of a particular thing exists, whether it's counting the blue cars or the yellow fruits or whatever the case may be. I don't know what you're going to count. We can count just about anything, right? How many of a particular type of toy you have or whatever the case may be. But you need the ability with a loop to loop through all of the things that you have. You need to use an if statement nested inside the loop to take the current item and compare it to something that you're looking for, some criteria, and if it's a match, increase your count. This is a standard algorithm, linear search, that you're going to be using off and on for as long as you're ever going to write any code. So here, I've got a count variable set to 0. I loop through my array list. My condition says if the value that I currently have matches some criteria, bump up my count. At the end, I'm going to return or print it. So this is kind of pseudocode, right? It's kind of real code mixed in with some non-real code, just so you can kind of get an idea of what's going on. Here, I'm using the for each loop to do pretty much the exact same thing. I'm just searching for something. I check item each time to see if it matches criteria, and then I bump up the count. So let's go look at this in code form to make sure that you got it. So let's try out the traversing an array list and manipulating the values, looking at the values with loops, because that's a very important component of important concept with computer science that you need to understand. So here we go. I've got an array list. I've added 34, 11, 18, 11, 11, and 99. So the premise would be, assume we have 10 million items in an array list. We don't know what those items are. We want to go through and determine how many times the number 11 exists
in that set of numbers. So in my example, I've added some values just so we kind of have something to work with. So I've got it all set up. I run it. I get 34, 11, 18, 11, 11, and 99. You know that by looking at that set of numbers, we know that there are 3. But what we want to do is write code that will actually count those 11s and give us that number. So what we need to do is we need to put in a for loop. And I equals 0. Okay, I is less than, this is not type, my typing's a bit on the shaky side today. There we go. All right, I plus plus. Okay, so you get the idea. So now I've got my for loop set up where I can go through and access all of the items in the ArrayList nums. So now what I need to do here, this is that pseudo code that we were just looking at. Here's where I need to ask a question. What am I looking for? So we're looking for 11s. So I want to know if the current value is an 11. And we have a get method that we can use. We can do this with, right? So I can say get I, and I can come over here and say equals 11. There we go. Get rid of some of these spaces because you don't need all that much, okay? So if that condition is true, now I got to do some stuff, right? So I'm just going to put a question mark here. So what we're doing is we're looping through, looking at all the values in the array list. We're determining we want to look for 11s. So we're saying get the value that's I, get 0, get 1, get 2, and then we're going to check each of those to see if they're 11. So what we want to do is we want to count the 11s. So if we're going to count the 11s, that means we got to come up here and say int count equals 0. And then in here, we're going to increment that count. We're going to say count equals count plus 1. We could say count plus plus. We could say a whole bunch of different things. However we wanted to do that. Let's just put count in here. Okay, and now we're going to run it. It's going to print out 3, because how many 11s do we have? We currently have 3. So what if we wanted to do this a different way? What if we wanted to do this with a for each loop, right? So let's just change this up to a for each loop. So we're going to say item colon nums, and then in here, instead of doing all the nums.getI stuff, I can just put item, and I can run it again, and what do you know, I still get 3. So to me, it's easier to do it with the for each loop than it is to do it with the traditional for loop. But as long as you understand the concept and the algorithm and you can put it in place, it doesn't matter which loop you use. Okay. But the idea is you need to understand if you had a giant group of values in an array list and you needed to go through and count the blue ones, the pink ones, the even ones, the odd ones. Maybe you want to go through a list of songs and determine how many of a particular type of song or how many from a particular artist exist. This would be the same algorithmic process you would use to determine those kind of things too. All right, looking good. Let's move along.
Now that we have the idea of traversing an array list with a loop and counting algorithms down, let's talk about removing items from an array list. We looked at some examples earlier. This was a review example. With remove, when you call the remove method and you provide a value, it's going to remove whatever item is at that location, right? So when I say array.remove 0, it's going to go to spot 0 and get rid of that item. So in this case, A would be at position 0. It would get rid of the A. B would slide down to 0. I would then add C and D. I would remove 0 again, which would get rid of the B, and leave C and D, which would have shifted down to position 0 and 1. So the key with the remove method is it gets rid of the value, decreases the size, shifts everything towards 0. So you got to keep that in mind, because now what we want to do is we want to look at how you would go through an array list and remove multiple values. In the prior example we looked at, we counted up the number of 11s. Now we're going to use that same example, go back through it and get rid of or remove all of the 11s. The thing you got to keep in mind was when you remove, it's going to shift everything down towards 0. So we got to be real careful when we remove to do it the right way so that we don't inadvertently skip items. Okay, so keep that in mind. So I'm doing this with a while loop. You can do this with a for loop as well. There's a couple different ways you can do it. I do it with a while loop simply because I like my spot variable and the size of my array list to be going in the same direction. Okay, if that makes sense. I could do this with a for loop too, but to me it's easier algorithmically when going over this for you guys, the students that are following with me here, to understand what's happening when I do it with a while loop. And I can show you in a second with a for loop too, but with the while loop, the way we got it set up is spot starts at size minus 1. And each time through the loop, we decrease spot so that spot is going towards 0, just like the items in the array list as they're getting removed are shifting towards 0. I would rather not have my spot variable going up and my items in the array list sliding down, because I don't want those two values to cross. Okay, so does that make sense? Hope it makes sense. When we get to the code right now, I'll make sure that you totally got all this.
So we looked at getting a count of how many 11s we had. Now let's go through and write a loop to remove all of the 11s. So in this example, we've got 34, 11, 18, 11, 11, and 99. So if we run this program through, it's going to print out all that stuff that's in the array list. Okay, so what we want to do now is we want to write a loop, go through, and every time we find an 11, remove it. So let's do this with the while loop. Let's set this up the way that I had it set up in the slides. Let's say int spot equals nums dot size -1. Okay, so now we got our spot variable where we want it. It's set to the end of the array, end of the array list, and now we're going to run our loop backwards. And so if you didn't know that you could run a loop backwards, you can run a loop backwards. You say, why did you not tell me this before? That's one of those best kept secrets. A lot of people don't know you can do this. A lot of people think a loop, for loop, while loop, any loop can only start at 0 and go up. You now know a very important secret that might have been held from you for ages, but now you know. Anyway, spot's equal to size -1 as long as it's greater than 0. Run through the loop. What we need to do right here is say if we're at an 11, we're going to remove the 11, right? That's what we want to do. Okay, and so after we do that, after we find an 11, regardless whether we find an 11 or not, right, our spot variable has to go down by 1. So if we find an 11, remove it. If it's not an 11, don't remove it, but we still, regardless whether we remove or not, we have to decrement. We have to decrement the spot. So what I'm going to say here is I'm going to say if nums, what was that? If nums.get spot, just like what we did before, if it's an 11, then I want to remove that value at that location. So I'm going to say nums.remove spot. Okay. All right, does this make sense? So I set spots to size -1. As long as it's greater than or equal to 0, I check the current spot that I'm at to see if it's an 11, and then I remove it. Okay, if it's an 11. If it's not an 11, I don't remove it. Either way, I got a decrement spot. So let's run this through and let's see if it works. Look at that. That's fancy. Worked perfect. You say, well, how could you have written this while loop where it didn't work? Well, I could start it at 0. So let's start it at 0 and then go up. Let's say as long as spot is less than nums.size. Okay. So this is going to be doing it the way that I don't want to do it, right? But either way, we'll do it this way so you can see what's going on. So now the problem with this is that my spot variable is going up towards size while my items in my array list, as they're removed, the remaining items shift towards 0. And what this is going to make happen is when I have 11s next to each other, it's going to remove 1, and then when the other 11 shifts towards 0 and the loop variable goes up, they're going to cross. So now when we run this, you'll notice that that 11 next to the 11 before the 99 didn't get removed. And it didn't get removed because it's incrementing spot no matter what. And you say, well, couldn't we put an else in here? Couldn't we put an else in here to only increment spot when we didn't remove? Well, sure, that would do it too. But that's kind of an extra step that you're going to have to put in so that you can handle the situation where your spot's going up when your items are going down. It's much easier to me to just do it with a spot variable or whatever variable it is that's at the size -1 going down the same direction as your items are being removed. So anyway, a couple different options. Could you do this with a for loop? You could. It comes out about the same way. But the way that you should really do this if you want to do it right, let's just make sure we got this down to an art. If we really want to do this right and make it the easiest to follow, you really should start your spot variable at size -1 and run your loop backwards. All right, like I said, you don't have to do it this way. You can put in all sorts of special cases to handle things and manage all this for you. But the more steps you put in, the more places there are for you to make mistakes. So anyway, here's an example of doing it with a while loop. To me, this is the easiest way to do it. If you want to do it with a for loop, you can work it around to do the same thing. And once again, now you know you can run a loop backwards if you didn't know that before. So you're getting more and more sophisticated as we go.
Now that we've done a thorough discussion of counting algorithms and removal algorithms with an array list, we're going to do a real quick look at a couple sorting algorithms. We're going to look at selection sort and insertion sort, and then later on we'll bring these insertion and selection sorts back and add on a merge sort discussion with the binary search as well. So in the counting and removal algorithms that we're using just earlier, kind of a linear search if you want to take a look at that. But we'll bring that back in later as we go. So anyway, first sort algorithm is selection sort. The way selection sort works is it goes through and you specify criteria that you want to use to find a particular item. Once that item is found, it's put in the position that you specify, whether it's ascending or descending. So this particular algorithm is going to put the items from an array list to integer items in order of increasing value. So it's going to put the smallest item and then the next smallest item and then the next smallest item and working its way all the way through. So it's got two loops. The outer loop drives how many times the inner loop is going to manipulate or examine the items. The inner loop is going to go through the items in the array list one pass after the other and look for the item that's being specified. In this case, the inner loop is looking for the smallest item. Once it finds the smallest item, it's going to put it in 0 position. And it's going to find the next smallest item and put it in 1's position and then 2's position and keep working its way through until it's got all the items where it needs to go. So let's look at some pictures. So here we have pass 0. We've got 92851. 1 should be in position 0. So the outer loop is going to drive the number of passes. Each time the inner loop runs, it performs a pass. So after the first pass, the 1 and the 9 will have been switched because the 1 needs to be in spot 0. It's going to make another pass, and the 2 would be the next smallest item. It's already in spot 1, don't need to do any work there. Then when we go to pass 3, 5 was in position 3. It needs to be in position 2, so it switches the 5 and the 8. And then the 8 is where it should be after pass 4. And then there's nothing to do after that because that would be the final check. So that's what selection sort is doing. Now, what you need to do, where you come into the equation, is you got to sit down with the code and work through it. Get a piece of paper, trace it out, get some cards from a deck of cards, manipulate the cards. You need to use whatever mechanism it is for you to use to make sure that this algorithm is familiar enough with you that you can apply it and recognize it. Here is an insertion sort algorithm. This one's a little bit more involved. Like I said, we're going to come back to this one as well as the selection sort later, but this is the basic code that you need. The way the insertion sort works is it basically slides items one direction or the other depending on how you specified for it to work. It'll lift an item, shift items, drop items. There's a lot of things going on in this while loop that you're going to need to sit down and familiarize yourself with, and that we will spend more time on later on. Right now, this is your initial view of selection sort and insertion sort. We'll come back to these as well as merge sort as we go on down the line. Okay, you can go out and mess around with these. I've given you some examples that you can look at as well. Okay, hopefully you feel better about an array list. You should be pretty solid now on how the methods of an array list work, and also algorithms, how a counting algorithm and a removal algorithm, how you can create those with loops and if statements and putting all those pieces together to create those algorithms. Also, we did a real quick look at selection and insertion sort. We're going to come back to that later. And also in the slides gave you a few slides in this section just for fun, where there are some collection methods and some additional array list methods that you can find useful that are not necessarily, things that you have to know, but things that you might find useful if you do competitions and you build programs outside of the normal framework of your school and your classes. you might find some of that stuff useful. So hopefully you got something out of this. Hopefully you feel better about working with ArrayLists. And now at this point, you just need to go out and crank some code and build some programs.